Welcome back, physics students. So now that we know all about mechanical energy and how to calculate it, we are going to practice using that new equation. So I have an example problem here for you, and I'd love for you to be following along on page 14 of your energy packet on your mechanical energy Cornell note sheet. So we have a roller coaster car at the top of a 50-meter tall loop. It has a mass of 4,500 kilograms when it's fully loaded and has 2,710 joules of total mechanical energy. We want to know what is the car's velocity at the top of the loop. All right, so the first thing we're going to do is identify our givens and our unknown. So we know the height of our loop is 50 meters tall. We're going to need that to calculate the potential energy. We know that the mass of our fully loaded roller coaster car is 4,500 kilograms. And we know that our total mechanical energy, ME or TE, is going to be 2,710,000 joules. We also know that the acceleration due to gravity is always 9.8 meters per second squared. And we are looking for velocity. That's what we want to know. All right, so we've got all of our givens and our unknowns. Then we are going to go ahead and identify some equations to use. So we know that mechanical energy, our new equation, is equal to potential energy plus kinetic energy. However, if I'm looking up at my givens and unknowns, I notice that I don't know the potential or the kinetic energy. And so I'm going to need to calculate those. And my potential energy equation is mass times gravity times height. And kinetic energy is going to be 1/2 times mass times velocity squared. All right. Then over where I'm going to show my work, I'm going to start off with my basic mechanical energy equation. But then since I do not know my potential energy and my kinetic energy, I'm going to go ahead and substitute in those equations. And so I'm going to keep mechanical energy. But instead of potential energy, I'm going to say potential energy is mass times gravity times height. And instead of kinetic energy, I'm going to say that kinetic energy is 1/2 times mass times velocity squared. All right, so now I've got my equation and I'm ready to start plugging in some variables. So instead of mechanical energy, now I'm going to put in the total mechanical energy of my roller coaster car. And I know that that is 2,710,000 joules. Now instead of mass, I know that this car has a mass of 4,500 kilograms when it is fully loaded. I know that the acceleration due to gravity, G, over in my givens and unknowns, is 9.8 meters per second squared. And I know that this loop is 50 meters tall. That's my potential energy. I can go ahead and calculate that. Then I'm going to add that 1/2 is going to stay in there because it is a constant. Again, I know the mass of my roller coaster car is 4,500 kilograms. And I am looking for that velocity. All right. Next thing I'm going to go ahead and do is I'm going to calculate that potential energy. And so for that, I'm going to take out my calculator and go 4,500 times 9.8 times 50. And that gives me 2,205,000 joules. All right. And then I'm going to keep that 1/2 times 4,500 kilograms times velocity squared. And the other side of the equal sign is still going to be my 2,710,000 joules. All right. Now I want to go ahead and subtract this 2,205,000 from both sides. All right, and I take 2,710,000 joules minus 2,205,000 joules. Again, I'm going to pull out my calculator. And I'm going to end up with 505,000 joules. And that is equal to my 1/2 times 4,500 100 kilograms times v squared. All right, now I'm going to go ahead and I'm going to multiply my 4,500 times 1/2. And that is going to give me 2,250 kilograms times v squared still. And the left side of my equation remains the same. It's still that 505,000 joules. All right, now I'm going to go ahead and I'm going to divide everything by this 2,250 kilograms. All right, and so 505,000 divided by 2,250 is going to give me 224.4, and this is going to be meters squared over seconds squared. And that equals now my velocity squared. Last step, I want to get just plain old velocity, not velocity squared, and so I'm going to square root my numbers. And the square root of 224.4 is going to end up being 14.97. The square root of meter per second, or meter squared per second squared, is just meters per second, and that equals my velocity. All right, so that is going to be my final answer. I found the velocity. So here I had to start out with my mechanical energy equation, and then I had to substitute in my potential energy and kinetic energy equations, and then plug in all of the numbers of things I knew. So this wasn't too difficult of a problem. However, it did take a lot of steps, and you have to be very careful to keep track of your numbers and make sure you don't get anything mixed up. So that's how we calculate using the mechanical energy equation. You guys have some practice problems on page 13 of your packet. That is what you're going to be working on next.